Okay, now in this video, we're going to learn about acceleration. So, acceleration is a unit of measurement, and its definition is change of velocity over time. Okay? So, in reality, it basically means moving faster and faster or slowing down. Okay? Basically, speeding up or slowing down. So, the yep. Now, if you want, you can do a demonstration there. I show you what's happening if grab grab anything on your table, a pen, a pencil, a rubber, a USB stick. Okay? So hold it in air and drop it. Okay? Hold it in air and drop it. If you do that, and if you look carefully, okay, what you would find out will be, say, initially, okay, say if I have a ball here, okay, then after I drop it, it starts to move down. Okay? It starts to move down to a ground or a surface. Okay? During the process of moving down, okay, the object, okay, what the object would do is it would move faster and faster and faster. This is because the gravity exert a gravitational pull on it, and it moves down at acceleration. It doesn't move down at a constant speed. So, yep, if you do it, say, okay, the speed at these two positions may be uh, compared with the speed at this position, you find the longer it experiences acceleration, the faster it is. Okay? Acceleration is is basically speeding up or slowing down. Okay, now let me show you demonstration on here. Okay, now what's happening here? I have a man. If I move it, now its position is there. If I move it, it will go down. Well, if I move the man to the left, the position graph will go down. If I move the man to the right, the position graph here would go up. Okay, now now say if I want the man starts from the left hand side, okay, and let me ask him to move at a speed of 1 meter per second. I hit play. Okay. Then what you can say is he moves at a constant speed, 1 meters per second. And on the graph, you can say a straight line means you see the line is increasing from minus 10, okay, to 10, so it moves to the right constantly with a steady speed. Okay. And on the velocity and time graph here, okay, the velocity doesn't change. Okay. The velocity is always 1 meters per second, as indicated on the graph. Okay, now have a look what's happening if I subject it to um, acceleration. Okay, just let me clear it. So say if I subject to acceleration with value 0.5 meter per second square, I will discuss the units with you later. Okay, so if I play now, what you can say is this man moves faster and faster and faster. If you look at the velocity, it moves faster, faster, and faster, and faster, then suddenly hits the wall and stops. And its acceleration is was 0.5. Okay, but if I change the scale of the graph, the acceleration was 0.5. So let me do it slowly again so we can, well, check. Now this time let me do it slow. Okay, let's subject it to acceleration 0. We used 0.5, so let's use 0.2. Okay, a slower acceleration. So let's play. Now the man starts really slow. As the time goes, it becomes faster and faster and faster and faster. Okay, become faster. This is it. We call this acceleration. So now, guess. Okay, say if I put the man in the middle, see. Okay, guess what's happen if I give him a minus acceleration, say minus 0.2. It would move backwards because acceleration is a vector quantity. If I write a minus number, it would move backwards. Okay. So yep. Now let's discuss the unit of acceleration and how do we calculate acceleration. Now, the unit of acceleration is written as meters per square seconds. It's Viet, or meters or meters square power of meters second power of -2. Okay. So what does it mean is, now acceleration is the change of velocity over time. Okay. It's the change of velocity over time. Okay. Just remember this little triangle here means the change. Okay. Change of velocity divided by the change of time. Okay. Velocity is meter per second. The unit of velocity is meter per second, and the unit of time is second. If I do it in math, so meter divided by seconds, then divided by second square, I have meters per second square. Let me write down like this: meters per second square, or meters per second square, or meters times second power of -2. This is where the unit came up. It really came up like this. Okay. Start from here, then it become like that. Okay. Due to mathematical symbols. But now, if you look at the original unit, it's meters per second divided by second. Now, it indicates how fast is the speed increasing. For instance, if I put the speed as 1 meters per second square, then it's 1 meters per second per second. It means that the object moves. Well, the speed of the the velocity of the object increases 1 meter per second every second. That's what does it mean. So, yep, just have a look. It starts slow. Every second, its speed increase 1 meters per second. So by the end of the 6 seconds, its speed is 6 meters per second because every second it increases. Yep, that's what does acceleration mean.